equals d of n k t. Well, p of d of pv is, of course, p dv plus v dp equals n and k are constant, so it's n k dt. Aha! This looks pretty darn good, doesn't it? Now we have an expression for dt. And I'll show you why that's so handy in just a second. It's just this divided by that. So, excuse me, dv plus vdp over nk. And lo and behold, we can substitute that back into the first law. Where's the first law? Here it is, right here. So we can substitute it back into the first law. M c sub v dt equals minus p dv. And we can substitute this in right here. So, give me just a moment here, times, and this is p dv plus v dp divided by nk equals minus p dv. Substituting m equals nm, our first substitution, m equals nm. When we do that, of course, m c sub v times p dv plus v dp divided by k equals minus p dv. And of course, we've got terms in terms of dp and dv. So let's now collect the terms together. To do that, of course, we'll put this term over here, leave this term alone, and it might be handy now to first divide multiply both sides by k and divide both sides by m c sub v. So before we move terms around, let's just think of it as p dv plus v dp equals, and what do we have? K over m c sub v times minus p dv. Now, v dp is going to equal minus p dv times 1 plus k over m c sub v. So I moved that term over there, factored out a minus p dv, leaving behind a 1 and a, let me check and make sure I have it just the way I want it. 1 plus m of, did I get this upside down? Maybe not. Maybe not. Does everything look good to you?
Yep.
It makes me real happy. What's upside down? I don't know. I think my notes have gone funky. Everything looks fine to me. Does it look fine to you?
Yeah.
I gotta stop writing notes later. Well, good. We're on the road to what we want. I can rearrange things like this. Let's see if this comes out the same as the See, I'll put the P over here, I'll put the V over there for obvious reasons. And did I keep the minus sign over there? I did. So I have dP over P equals And then I seem to have kept the negative sign here, dv over v times 1 plus over mc sub v, like that. Now, if I factor out k over mc sub v in both places, v over v times k over mc sub v, and then this will be, of course, mc sub v over k plus 1. Looking fine to me. I don't know what looked funny on my notes. Now, what interesting thing did I do? How interesting is that? Notice here, let's see if this looks legitimate to you, dv over v, and now notice the c sub v, if I keep that out, c sub v, then I can write here k over m, let's not get too excited about that for a second. Let's see, I have this, yeah. And I see, I got rid of the m. All right, so now I get times, I'm a little concerned about this because my notes went funny and I'm not happy about this, but let's see if this turns out right. K over m plus c sub v. Now, if I put that back in there, yeah, it looks like it works. But all of this is nothing more than c sub p. Hence, therefore, we have ep over p equals minus dv over v times c sub p over c sub v. There's the c sub p, there's the c sub v. So we did a little bit of algebra in a strange way, simply to force this to be c sub p, which I think I've erased already, but we defined that earlier as c sub p. C sub p plus k over m was c sub p. So now, that's nothing more than minus gamma dv over v. We finally have come around to an expression which will be helpful. If I integrate both sides, what do I get? I get the integral of dp over p equals the integral of minus gamma dv over v, but gamma is a constant, so we get ln of p final over p initial equals minus gamma times the ln of v final over v initial. But you remember what happens when you put the gamma in there. You get ln of p final over p initial equals ln of v initial over v final raised to the positive gamma power. You exploit the negative sign by flipping the subscript, by flipping the fraction, changing the subscripts, and the gamma becomes a positive power. But of course, if their logarithms are the same, the arguments must be the same. Hence, therefore, p final over p initial must equal v initial to the gamma power divided by v final to the gamma power. And we've actually arrived at the location we need to be. That is that p final, v final to the gamma power equals p initial, v initial to the gamma power. We now have an equation of an adiabatic.